Hello friends, welcome to the session on digital image processing. In this session, we'll be discussing about image filtering. It is possible that whenever we have any digital image, then to this digital image, we can apply some mask, and this mask can be called as a filter. So when we apply some mask, then there is some enhancement in the digital image. So in order to achieve these enhancements, we can apply the different filtering techniques that are available. And these filtering techniques will improve the given image. So in this session, we will see what we mean by filtering of the image and how it is possible that we can apply the different filter masks to the image. We will see what are the different functions available in the Scilab in order to perform the image filtering. Friends, as you know that you are viewing this session on my YouTube channel, and you can subscribe to the channel so that you can watch many other educational videos on the various topics of the subjects of electronics and computer science. So let us start the session with the question, what we mean by the image filtering. Now we know that whenever we think of a digital image, then the digital image can be given by a two-dimensional function f of x comma y, where x and y are the spatial coordinates, or they are called as the plane coordinates. And this function f will return us a value, and this value corresponds to the intensity of the different pixels from which the image is constituted. So as shown in this window, you will find that the image will basically consist of the small dots, and these dots are called as the pixels. And the function f of x comma y will return us a intensity value of each pixel. So this function can be tabulated in the form of a matrix, where the matrix will consist of the different rows and columns. So these pixels will form the digital image, and the digital image is to be called as a digital when there are a finite number of elements, and each element will have a particular location, and each element will have a particular value. Now, whenever we perform the image filtering, that is being called as a spatial filtering, or sometimes it is also called as the neighborhood processing. So this process of image filtering will consist of 4 steps. Initially, we need to define a center point x comma y. So suppose we have some center point in the image x comma y. Then we will perform an operation on the pixels that are in the neighborhood of the center pixel. So we will consider the neighborhood pixels surrounding the center pixel. Say for example, we can consider 3 pixels on all the sides of the center pixel. And then this result of the operation is being treated as the response at that point. And this process is being carried out for every point in the image. So the computations that are being performed on the pixels of the neighborhood, if these computations are linear, then this operation is being called as the linear spatial filtering, or sometimes we call it as a spatial convolution. And if it is not linear, then in that case, such filtering is being called as a non-linear spatial filtering. So in linear filtering, each pixel in the neighborhood is multiplied by a coefficient, and then it is summed to get the result. So the coefficients are arranged in the form of a matrix, and this matrix can be called as a filter, or it can be called as a mask, or it sometimes we call it as a convolution filter, or sometimes we call it as a kernel. So for example, if this is some image given to you, then it is possible that you can apply some filtering technique to this image in such a way that we can get some enhanced image as a result of this filtering. In Scilab or in MATLAB, there is a function that can be used for filtering of the images. And this function is called as IM filter. So the syntax of this function is Z is equal to IM filter. In the bracket, we mention the various parameters such as image IM, F, then the bound, and then the size, OP, output size, OP, SZ. So IM is the image that is to be filtered. F is a 2D filter. G is the filtered image, that is the output image. Bound is the type of the boundary values or keyboards. And output size is the size of the output image that can be either a full or the same size. So image filter an image IM with the filter F. So this function is very useful whenever you want to filter any given image. And this image, if it is a multi-channel image, then you will find that on each channel of the image, the function F will be applied separately. So the input image pixel values outside the bounds of the image are assumed to be equal to the nearest array border value. Say for example, if I have been given some image, then initially I need to read that image by using the imread function. Then I can make the use of the F spatial function in order to define the filter. Filter is equal to F spatial, and here you can write the different default filters that are available in Scilab or MATLAB. So for example, I can make the use of the standard filter called as Sobel filter. And then I can get the output image G by using this IM filter function, IM comma filter. And then I can show the image. So if this is an input image, and if I apply the Sobel filter to this image, then the output image will look like this. Also, if this is an input image, and if I apply some Sobel filter to this dog image, then you will find that you will get an image as shown in this window. So there are different spatial filters available with the F spatial function. Say for example, we can make the use of the filter name as an average, where it is an averaging filter and the default is 3 by 3 matrix. We can make the use of the type as disk, where a circular averaging filter with radius R with the default radius as 5. We can make the use of Gaussian filter, where the Gaussian low pass filter is being applied to the image and the default are 3 by 3 matrix. Then we can make the use of Laplacian filter, where the shape is specified by the alpha and the alpha is always in the range of 0 to 1 and the default value for the alpha is 0.5. We can make the use of log as a Laplacian of the Gaussian log filter. We can make the use of motion, where output, this filter will output an image when the convolute with an image approximate a linear motion of the length of pixels. We can make the use of private filter, where we can get an output 3 by 3 mask. We can make the use of Sobel filter, where the output is 3 by 3 Sobel mask that approximates a vertical gradient. It is also possible that you can make the use of unsharp filter, and this will output a 3 by 3 unsharp image. Say for example, if I make the use of this unsharp filter and if I apply it to the image, then I will get the image as shown in this window. So one can easily observe the sharpness has increased when we apply the unsharp filter to the image. So thank you friends for viewing the session. Hopefully you have understood how to apply the different filters to the given images. Thank you all.